This video is in preparation for your physics exam. So the first thing I'm going to say to you is, in preparation for your exam, please make sure that you review each of the individual topics that you know that you have as weakness areas. So in preparation for this, there is a series of revision summary videos which you can utilize to help you kind of plug gaps in your knowledge on any particular topic areas. Obviously, you can kind of watch either all of them, you can watch the selection of them, depending on what your sort of strengths and weaknesses are. Obviously, you decide how best to use your time at this point. So this video is going to talk about some key exam technique that you need for physics, just to make sure that you don't lose marks for really silly things, what we often term unforced errors. So what I'm initially going to cover is some really important sort of overview of some of the maths things that we need to make sure that we get right and we should know and are expected to know for the exam. And then the second bit we'll then look at an example of a paper and just look at some things to just be really mindful of in terms of exam technique. So in terms of the mathematical requirements, I'm just going to go through each of these. You may want to pause the video momentarily so that you can read what is actually required of you in each of the sections. So that's like a summary of all of the math skills that you can be assessed on and will be assessed on, and it's important to recognise that across the two exams. So for example, at some point you will definitely have a graph that requires you to use relationships in the form y equals mx plus c. In other words, at some point you must work out a gradient, at some point you must work out areas under the graph, at some point you will be asked to rearrange equations. All of these skills will come up on the exam, so it's really important that you know that up front, that they're going to be tested, and therefore if you learn how to do those skills, that is bankable marks in your examination. Okay, so the first thing that's really important is calculations. So you're going to get a lot of calculations obviously in your physics exam. Please make sure you use the 4 steps, and the reason I want to stress this is how the mark scheme is structured. So it does not matter what the command word is, it doesn't matter whether it is calculate, whether it is show, whether it is determine, whether it is verify, whether it is estimate, whether it is conclude. All of those command words all have the potential to assign you marks based on the 4 steps. So step 1 is write down the key information from the question clearly. People often overlook this step more than any of the others, and this is the one I want to implore you to do the most, particularly if you get a problem that you are not immediately sure of the answer. So sometimes you will just know the answer and you'll be like, right, I know exactly what I'm doing, I'm going to write the equation, I'm going to put my numbers in, and I'm going to skip to step 2. But as you go through the paper, the questions will get harder, and the more complex the calculation, the more it is important that you kind of take a moment, you stop and just write down everything you've been told, and you put a question mark next to the thing that you've got to calculate. This can be worth marks. So for example, if it was a question that required you, for example, to use SUVAT in paper 2, stating, for example, that like the initial velocity is equal to 0 sometimes is worth a mark. There are other scenarios where writing down what you've been told matters, and it also encourages you to change your unit straight away, which again is on the mark scheme and will score you marks. So please don't ignore it, it is worth marks. Then you have to write down what equation you need. So sometimes that will just be you looking on the data sheet, other times you can remember it, but obviously write it down, make it clear. Then you stick your numbers in and rearrange it if it's necessary. Both of those 2 steps will score you marks. And then obviously don't forget to work out your answer, and never ever forget to use the units. And one additional thing I will add to that is never forget to use the correct number of significant figures or decimal places that is suggested in the question. So let's look at some points of this. So first off, you will get a data sheet in your exam. Please use it fully. Now, depending upon the difficulty level of the questions, some questions the equation will be given to you in the question. Others it will not. So if you are not sure immediately of what the equation is, go to the data sheet, look for the equation, make sure you double check, and make sure you check really carefully what each of the components is worth. Let's say, for example, you are struggling. Let's say, for example, you get to a question and the question tells you you've got to work out momentum, and you're struggling because you can't remember the equation for momentum. So come to the data sheet, and the first job is to find all of the equation reference to momentum. Okay, and in doing that, that will help narrow your options and will guide you. Obviously, in this particular case, you'll see there's only one equation that's covered here on this page that refers to momentum. That's not to say there aren't possibly others, but that's what you're given. So that would be your starting point. Kind of use that as your sort of initial guide. And some of the equations on here come up very, very frequently in the exam. Here is a list specifically from the higher tier ones, and obviously for triple, it's highly likely that some of these will appear. You'll notice on this list you will see a second equation that makes reference to momentum, and that's an example of where you then need to be selective. Or do I have time and mass, or do I have mass and velocity like the previous example, and sort of like force in this one, for example. So it's really important alongside all of that you know not only the equations but what the units are. So here's a really quick example. You might just want to pause and have a go at this. I would hope this one is ridiculously easy because these are just very standard units that you should be aware of. You should have no difficulty with that. So we'll talk about it for the units in a moment. So just going back to the 4 steps. So there are additional videos that you can watch sort of going through this, but in summary, step 1 is highlight the key bits of information in the question. Obviously in your exam you're more likely just to underline it. Always underline the command word because that dictates how you're going to get marks, and then obviously what you've been asked to calculate. Obviously then write down everything the question's told you, put a question mark next to the thing you've been asked to calculate. That's step 1. Step 2 is then subsequently to write down the equation, which in this case would be power is current times voltage. Then put your numbers into that equation, which in this case is 13 times 230, and then work out your answer, not forgetting the units. Okay, so that's just an overview of the basic process. One thing I want to stress about this, I'm going to show you some really quick calculation examples. So you can see here this is 3 marks, so you can see you're getting a mark for the unit. They're being nice here, they're giving you a choice. And you're not getting marks here for step 1 or 2 because they've given you the equation you need in the question. So you can see the mark scheme is basically just covering steps 3 and 4 of you putting the numbers into the equation. You aren't required to rearrange it in this case, and then obviously you're getting the units. Here's another kind of calculation. This time again you're given the equation of the question, so you can see the mark scheme here gives you marks for steps 4 and step 3 and step 4. Again, another example, this time for kinetic energy, and this you can see you're getting marks again for those same 2 stages, putting the numbers in and working out the answer. Now sometimes you're not given the equation, sometimes you're going to get marks for that separately, as like in this example, where you would get a mark for that, and then steps 3 and steps 4 follow on naturally in the rest of the question. In this example, it says explicitly in the question, use the physics sheet. So they're expecting you to look up the equation and obviously then subsequently use it. And obviously the latent heat you've been given in the question. There's one other little pitfall here to watch out for. This is a huge mistake, is always check that your units are correct. So here you can see you've been given the latent heat of fusion in kilojoules per kilogram, which is wrong. It needs to be in joules per kilogram, and so you go times it by 1,000. So you can see that's why you get a mark for that first. That's why in step 1 it's really important to write down to make sure the units are right. It's really important that you can rearrange your equations. There are videos you can go and watch on that specifically if you don't know how to do it. The main thing is just make sure you isolate the term that you're interested in, make it lonely, put it on its and do the opposite of any functions. Now, just in summary of units, I'm going to go through this reasonably quickly, but it is important that you do have a basis of all these, so this is just so you can check your units. Just starting off with the base units, first thing I just want to highlight is you must always make sure you are doing your masses in kilograms. So converting grams to kilograms is really important. Always in meters, always in seconds. So again, hours or minutes to seconds important. Generally, we use degrees C in temperature calculations. For current, obviously we'll use ampere. You will get kiloamps, milliamps, megaamps, etc. So you know the prefix is important, which we'll cover in a minute, and obviously moles are more important in chemistry. So there's a whole selection of derived units here, which I'm just going to go through and just hold. So I would encourage you just to pause the video and make sure you are familiar with all of those, because those are very common units that you should be aware of. And obviously these are all capital letters because they're all named after a person, with the exception of the one for density. Here is a bigger list of units. Again, I would pause the video at this point, have a go at writing each of these down and making sure you can check you've got the unit, and then obviously check the answers in a moment. So going for the answers really quickly, I'm just going to put those on the screen, and then you can just go through them as you need to. But all of these are units that you should be familiar with and be aware of in preparation for the exam. Unit conversion, again, is a topic that's covered within this. So the main thing I would encourage you to do is make sure you have clear in your mind what one of something is. So obviously 1 kilometer is 1,000 meters. If you know that, you can just ask yourself the question, like, how do I go from 1 to 1,000? Well, clearly I times it by 1,000. Same thing, 1 minute, 60 seconds. So annotate it on like so. There just been 2 really simple examples, and then obviously going in whatever direction it describes. Okay, so then I would apply that to the question. So if I was going from say 2.6 kilometers, I would times that by 1,000, and that would be 6,200 meters. So there are some other examples of here that again you can then use. I'm just going to put these up, and again I would encourage you to pause the video for a moment and just consider each of these and just make sure you're happy with them. And we can do this with mass, we can do this with times, we can do this with distances. They all work. So there's lots of different ways we can do this. And you can also do it between squared units and reciprocals. Obviously, if I'm going from centimeters to meters, I'd times by 100. But if I'm going from centimeters squared to meter squared, I would times by 100 squared. Linked to this is obviously knowledge of the prefixes. This is the list that you should be familiar with. This will appear somewhere on the exam. The question is just simply where. So making sure you're familiar with this and knowing each of them will get you easy marks if you've learned this table. So please make sure you are familiar with the prefixes. Okay. Here is a quick hinge question that you can have a go at. Again, I'll pause the video, consider it, and then the answer will appear in a moment. Okay, just obviously summarising them all. So C is the right answer. Micro, milli, kilo, tera. And here's one example that's actually more for paper 2, but you can see that obviously they come up very frequently when linked to the electromagnetic spectrum, obviously because of the high frequencies and small, well, high to low wavelengths that occur on there. Another thing that you might be asked to do in your exam is to give your answer in standard form, and obviously make sure that you give that there's only one number between 1 and 9, and then the decimal, and then obviously any other numbers that you wish after that, and obviously it's raised to a particular power. That's how far you move it. So an example might be the radius of an atom, when obviously you can count how far you need to transmit that 1 to take it back to the units column, and obviously that would indicate 10 to the minus 10, which obviously you can count your way along if you need to. So feel free to pause that if you need to take a moment on standard form. So just in addition to that, just having a quick look at the paper, make sure that when you get your paper that you take time to read the details on the front. You must have your scientific calculator, a ruler is necessary, you will have the equation sheet, make sure you've got that, and take a moment at the very start of the paper to read through and check what all the questions are, so you've got just an overview of how you're going to allocate your time. Obviously the paper is 100 marks, and you'll have 1 hour and 45 minutes. Make sure that you plan to be ahead of time to give you time to go back and check. That's really, really important to do. When you actually get into the paper, make sure that you underline the command words in each question, because obviously that's going to indicate to you how you should respond. Keep that in mind, and obviously pay attention to the number of marks that are indicated in square brackets, as so. One particular thing to highlight is make sure you know where the 6-mark question is in the test. So in this particular one, it occurs in question 3. So we have the required practical, when you first got to add an ammeter and a voltmeter, by drawing the circuit symbols, obviously ammeter in series, voltmeter in parallel. And then you are given the 6-mark question to describe how the student would obtain the data, including information on the hazard. Again, for 6-mark questions, make sure you think about what the mark scheme is going to look like for that, because the key thing is it's a banded response. So you've got to think, how would I get a 5 or 6-mark response? And that's usually by making sure you've answered all parts of the question. So make sure you underline every command word and each key piece of data. In questions where you are doing calculations, I would strongly encourage you always to identify the numbers in the question. So a quick example of that can be seen here, where you've got to state the equation, which again use the data sheet for, and then underline these numbers in the question, again checking for units that you need to convert or not convert. The final thing to be really mindful of, just as you're going through the paper, which I'm just going to show you very quickly at the end, is that the questions increase in difficulty generally. So make sure that you plan sufficient time to make sure that you don't run out of time on the last question,